Last video we have seen the analysis of half wave controlled rectifier with R load. So in this video we will see a single phase half wave rectifier circuit, half wave rectifier, controlled rectifier, half wave controlled rectifier with L load. L means inductor. Okay, so before that you need to understand the property of an inductor. This is very important because in almost all the power electronic applications you come across a circuit normally with inductance, and inductance they normally do some kind of polarity arrangement. So this is the basic thing that you need to understand. Suppose that this is an inductor. If the current flowing through the inductor increases, okay, the current flowing through the inductor increases, then di divided by dt will be positive, because the voltage across the inductor VL is equal to L into di divided by dt. When the current flowing through the inductor increases, rate of change of current will be positive. Okay, whenever the current flowing through the inductor decreases, okay, di divided by dt will be negative. Okay, now you have to write the property of, you have to note it down, the property of inductance is to oppose the change in current by developing an appropriate voltage, in magnitude as well as in polarity. So this is the property, is to oppose a change in current by developing an appropriate voltage in magnitude and polarity. The meaning is, suppose that this is the current flowing through the inductor. The current flowing through the inductor increases. Assume that this is decreasing, increasing and decreasing. Okay, so whenever the current flowing through the inductor increasing, this is the interval. Okay, so during that time the inductance will develop a polarity like this. Current flowing through the inductor increases, so a polarity will be developed across the inductor such that it will oppose the increase in current. Similarly, here the current start to decrease, so definitely the polarity of the inductor reverses just to oppose the decrease in current. So this happens automatically in an inductor. Whenever the current increases, it develops a polarity like this. Whenever there is a chance for current to decrease like this, immediately the polarity of the inductor reverses. So here also plus minus, when the current decreases, this is minus plus. So these things are very important, you need to remember before doing analysis with inductive load. Now a half wave controlled rectifier with inductive load. There is a source voltage SCR. Assume that the triggering circuit is there, and instead of a resistive load I am going to connect an L load. So this is output voltage V0 and this is the input voltage Vs. Okay, so when the switch is on, we know that output voltage is equal to input voltage, which is, so what is output voltage? L into di divided by dt. What is input voltage? Vm sin omega t. So from this, if you find the value of current, I is equal to Vm divided by omega L, 1 minus cos omega t. So when will the I reach its maximum value? Whenever the value of omega t is equal to pi, I reaches I max. Okay, so the conclusion is, in an L load, current reaches peak value at omega t is equal to pi. So these things are again very important. We have already seen for a resistive load, current reaches its peak value at omega t is equal to pi by 2, right? Because the voltage and current in a resistor follows the same fashion. So whenever the voltage reaches peak value at pi by 2, current also reaches the peak value at pi by 2, that we know. In an inductive load, this is at pi. Okay, similarly if you do the analysis of the combination of RL, resistor and inductor, I reaches I peak somewhere between pi by 2 to pi. So these points are very important, because for drawing the waveforms these things are very necessary. Okay, so resistive load, I reaches peak value when omega t is equal to pi by 2. Inductive load, I reaches peak value when omega t is equal to pi. In an RL load, I reaches its peak value between pi by 2 to pi, depending on the value of inductance. So this is very important. So based on that we can draw the waveforms for an inductive load. This is very simple. You draw the source voltage, there is a CR, and you draw this inductor. This is output voltage V0. First you draw the input voltage. Okay, this is Vin or Vs. This is pi, this is 2 pi, this is 3 pi, etc. Okay, first I will draw the current and then I will draw the voltage. Okay, you start with any angle. Let's say you'll start the triggering at this angle. This is a triggering pulse you are going to supply. Okay, so what will happen after this instant? After this instant, what happens is inductor current SCR is on. Once the triggering pulse is there, SCR is on. We have already learned that I reaches its peak value at omega t is equal to pi, right? So immediately current flowing through the inductor, switch is closed, so current start to flow through the inductor. So as I have already told you, whenever the current flowing through the inductor is in this way, inductor develops a polarity like this to oppose the flow of increase in current. Okay, so current slowly increases and it reaches its peak value at pi. Okay, and after pi, what is happening is a negative half cycle, pi to 2 pi. SCR will suddenly turn off, right? When SCR turn off, what will happen to the flow of current? There is a break in the flow of current, which means current start to decrease through the inductor. Whenever the current start to decrease through the inductor, what will happen? Inductor will develop a polarity in the opposite direction just to decrease the decrease in current. So current slowly increases and finally it reaches this value. So whatever it is gained in the positive half cycle, like that it has to decrease in the negative half cycle. Okay, so you almost get a continuous conduction, and depends on the value of this inductance, it can extend up to this 2 pi plus alpha. Here also it start like this, it may go like this, slowly decreases, and the next 2 pi plus alpha inductor current again start increases, reaches peak value here, and it continues. So if you analyze this waveform, you can see that from the starting period onwards, or if you if you analyze the waveform at the steady state, if you understand that for all the full cycle the current is present. Okay, even though you feel that the switch is off, actually the switch is not turned off because the inductor does not allow the instantaneous decrease in current. So almost all the time you get a full flow of current, which means full time the circuit is on. So what is output voltage? When the switch is on for the entire duration, what is output voltage? You get the source voltage. For the entire duration, you will get the source voltage. So this is the property of inductor. The average value across the inductor will be always 0. This is happening in a pure inductor. Okay. Now in the next video we will see what is happening into an RL load.